NoSQL databases such as Redis have become increasingly popular due to their focus on very fast query speed and flexibility of schema, among other reasons. In this video, we will look at how a Redis cluster using the Redis on-Flash data storage tier can be deployed on the HPE Apollo 4200 Gen 10 Plus platform. We'll show how the tremendously dense storage capacity and processing power of Apollo can produce a high-performance Redis deployment with the extreme low latency that Redis databases require. Redis is unique among NoSQL databases and databases in general in that it traditionally has been an all-in-memory application. Redis databases weren't even allowed to be larger than the available memory space to ensure that the entire database would always operate completely in RAM. While this has always made Redis one of the fastest performing and lowest latency databases, it also means that Redis databases need to remain relatively small and almost always need to be sharded across multiple server nodes. The open source version of Redis still operates under these restrictions. However, the commercial version, called Redis Enterprise, has a relatively new feature called Redis on Flash that reduces much of the restrictions. Redis on Flash creates a tier of available storage, only using NVMe drives, that Redis can use to house less used data within the database. This lets the current workload still reside completely in memory, but allows the database to grow larger than the available RAM without necessarily requiring sharding and multiple hosts. The HPE Apollo 4200 Gen 10 Plus system is ideal for applications that require a very dense onboard storage footprint to both maximize storage capability and minimize latency. The massive NVMe storage capacity provides an optimal home for the Redis on Flash tier that we will be highlighting today. In addition, a single 4200 Gen 10 Plus system supports a total of 64 CPU cores and 4 terabytes of RAM per processor, perfect for high performance and memory intensive requirements for a database app such as Redis. So let's talk about how we can deploy a Redis on Flash tier for a Redis cluster using Apollo 4200 Gen 10 Plus systems as the hosts. We put together a test environment where a 3-node Redis Enterprise cluster was deployed on 3 Apollo 4200 Gen 10 Plus units. We divided the testing into 2 phases, one with a single NVMe drive hosting Redis on Flash per host, and one with a software RAID 0 set using 3 NVMe drives per host. We ran 5 different test scenarios for a single Redis database. We started with a basic database, no clustering, no replication, no persistence. We then moved to a cluster database with 2 shards. We took that same 2-shard cluster and added replication for a total of 4 shards. We repeated the same environment as test 3, but we added persistence. And then in test 5, we repeated the same environment as test 4, but we changed the database settings to force the spreading of the shards across the nodes and make all the shards primary shards. To do this, we had to turn off replication because the Redis test environment license that we were using only allows for 4 shards. We used the Redis performance test tool memtier benchmark that comes with Redis software to populate the database and run loads against it. We followed the examples listed in the Redis Enterprise documentation under Benchmark a Redis on Flash enabled database, found at the link shown here. One thing to note about setting up the software RAID set. Redis has a built-in script in the Redis install directory called prepare_flash.sh. This script goes out and finds all the unused NVMe drives in the host and combines them into one large RAID 0 stripe. Because of the huge NVMe capacity in the Apollo 4200 Gen 10 Plus hosts that we used, that would have resulted in dozens of NVMe drives included in the set. Not wanting to allocate all of those drives just for our Redis deployment, we manually created the 3-drive RAID set using the Linux mdadm command. We duplicated all the settings for the database listed in the benchmarking guide, including setting the database memory limit at 100 gigs and the RAM to flash ratio to 30% or 30 gigs. This ensures that both RAM and the flash storage would be used during the test. The results for the testing were impressive as compared to the expected performance numbers listed in the benchmarking guide. The expected numbers were around 160,000 operations per second without replication and 115,000 with replication enabled. In both cases, average latency was expected at below 1 millisecond. In these graphs, the expected numbers are represented in blue, while the Apollo test numbers are represented in green. As we look at the graphs, we see that in most instances, the Apollo hosts were able to get Redis to put out significantly better performance than what should be expected for both throughput, which you see on the left, and latency, which you see on the right. Performance significantly improved when sharding is introduced in test 2, which makes sense as that allows more concurrent client query jobs across the hosts. However, simply sharding can't account for this level of performance. That's where the Apollo systems take over. Adding replication or persistence in tests 3 and 4 didn't cause any performance degradation, and neither did switching between single disk and the 3-disk software RAID set. While we once again see in test 1 that Redis just runs better in a sharded environment, we also see more than double the throughput and less than half of the latency that Redis would expect in more real-world test configurations. This just points to the superior performance capabilities of the Apollo hosts across CPU, RAM, and NVMe disks. Bottom line is, since Redis recommends using sharding and replication in production environments, and since Apollo shows almost double or even triple the expected performance for throughput and a half or a third the expected latency, any Redis deployment on Apollo is very likely to outperform commodity servers on the stats that matter the most to Redis users. For more information on the Apollo 4200 Gen 10 Plus system and the other elements that make up this solution, please check out the link shown here. We also recommend checking out the HPE Technology YouTube channel for other HPE workload solutions for NoSQL users. Thanks very much for watching.